In this session, we'll be showing you how to work properly in Millturn. I'll be explaining in these sessions exactly what we have now inside each one of these menus over here. This is done so that you can understand exactly how to work with Millturn, with all its operations and all its parameters. We'll start by first looking inside CAMPart. If I open up our CAMPart, of course, as in before, we choose our machine. In this particular case, we're using an Intergex 300. In our coordinate system, there weren't any changes made, so we'll leave it exactly the way it is right now. Now, we've made some changes in our stock to make it a lot easier. If I were to open up our stock, our default option is using cylinder to create a cylinder around the part. These options that we have over here were all created so that you do not have to use Sketch, minimizing the use of sketches. By not using sketches, it makes your programming go a lot faster and a lot easier to work with. All you have to do is choose your cylinder. You can have how big it is over on the right-hand side as shown over here. Also, how much it sticks out on the left-hand side, your external diameter, how much you want it to be bigger. And if needed, you can also create an internal diameter if the stock comes with a hole inside of it already. Since most of the turning is done with cylinder, that's why this is our default option. Of course, we have different options as well, such as box, revolved boundaries. All of these are over here. The default is cylinder because that's what we use most. Next, we have our target. If we go into our target, we've improved by our target by, when we click on target, you'll note it goes directly to the point of where you choose your target. We had that window in between this to choose a target. We've done away with that window so we can go directly to choosing this target. And all you have to do is, just as in before, just click on the part and choose your target. The rest of the options stay the same, so we just leave exactly everything the way it is. Next, we'll go into our machine ID. What the machine ID actually does, it exactly explains all of the kinematic of the machine itself. All the different turrets, all of this, and I'll get into that in a moment. Also, we have the controller definition, where it explains everything, all the options that the machine has inside its controller. And last over here, we also have our user-defined parameters. These are all the parameters that were in your miscellaneous that the operator usually wanted on this particular machine. Now let's get back to our machine definition. Now, before I continue, let me first open up my machine simulation itself. If we take a look at the machine, you can see that this is an Intergex 300 that has the main spindle, it has a back spindle, it has an upper turret, it has a lower turret as well. And this is actually one machine as you see right now, but this is later on broken up into 4 separate machines, or what we like to call sub-machines, and we'll talk about that in a few moments. What do I mean by sub-machines? What I mean by sub-machines is that we have 4 different ways of working. We can work with this axis over here, the B axis over here, together with the main spindle, as well as working with it with the back spindle. The same thing with our lower turret. Our lower turret can work with the main spindle as well as with the back spindle. So we actually have 4 sub-machines within this particular machine. I'm going to close the machine now, and we'll go back to defining our machine ID. Now, as we see in our machine definition, we have all our different devices. We have a list here of all the devices that we can put in here as well, such as turrets, tables, tailstock, all of these standard devices, and the way of putting them in, just by simply taking them and grabbing them and putting them wherever you need to put them. We have also custom devices for newer machines where none of these are defined yet, but you can define any new device by using custom device. It should also be noted that all of this is usually the work of the post-processor support staff. They are the ones that actually set this up, and they only set this up once. And once it's working, you do not have to fill in any kind of parameters in here. All of this is done already before you start working. So we're just showing you that you should know exactly where all of this is coming from. Now, I had mentioned before about the different turrets. As you can see, we have here 4 different devices, the 4 different submachines that we wanted. The person who created this post-processor, this particular machine ID, created UT. You can call it any name you want. He called it UT for upper turret, LT for lower turret, MS, and BS. Back spindle, main spindle, and back spindle. If I were to open up, for example, my upper turret and click on, say, axis, you can see exactly what we have here with all the axes. You can also see all the information on all the different axes that we have over here as well. Options, everything we have in the options. Upper turret, again, everything we have in this turret itself. The same thing with our lower turret and with our main spindle and back spindle as well. Now let's go down to our submachines. As you see right now, there were 4 submachines that were created for this machine. And we can see them over here. Now let me click, for example, on our upper turret main spindle. And as you see over here, we have our upper turret together with our main spindle, upper turret and main spindle. And you can see that this operation type is milling and turning, that this supports both milling and turning. All of these devices are also created. All of these submachines were also created as well. And let me just go into my last one, and you can see that this is the lower turret and back spindle. But the lower turret can only support turning, so therefore the operation type is turning. This will help you later on when you create your operations, that when you pick it, you have exactly open whatever you need to have open for that particular type of operation. Now let's talk about our tool table. In our tool table, we've made many improvements as well. As you can see, we have a complete new look to our tool table. On top over here, we have whether we want to work in showing, we can see our turrets, we can show our milling tools, show the turning tool, all the different type of filters we have is all on top over here. On the bottom, we can add turning tool. All of these, as far as renumbering, import, export, all of these are down over here itself. If we go into the tool itself, you can see we also added our issue of turrets, which turret we want to have the tool in, whether it be the upper turret and lower turret, as defined in our machine ID. We also have here our stations, positions, all of this is over here as well. If we go down here, we can also see we have our cutting edge direction, whether we're working left or right. One other thing that's very important is also our advanced to the mounting. If I were to open up advanced, you can see we can actually control the angle of our mounting itself, of the turret itself. For example, our upper turret has actually a B-axis to it as well. So we can control the axis of it. I'll open up the tool so you can see exactly what's going to happen the moment I turn it. If I were to say change the angle, you can see the angle changes exactly the way I want to have it on the machine itself. And this is how we can control the angle of our tool in the machine. Now, let's go and create a new turning tool. If I were to create a new turning tool, you can see we've added all the different types of composite tools that exist. In addition, we still have our old tools, so we also still support the old tools that you've had before. Let me take, for example, one of the composite tools. I'll take the external turning. And as you can see, we have all the different types of inserts over here. You see all the inserts? If I were to open up this window over here, you can see all the different types of inserts. I can choose this one, and this insert comes up. If I were to go into holder, we have also the different types of holders here as well. Let me go back into insert. We can define all of our diameter. We have the outside diameter. We can choose it exactly from what we have here. These are the standards of these type of inserts. You choose just the diameter that you have over here. The same thing with the corner radius. You can choose from this list all the different types of corner radiuses that you have on these type of inserts. Let's go into our holder, and you can see that this insert is automatically fit to the holder that it needs, with all the different sizes as well. If we open up the first window, you can see the insert clamping that we have. All of these, you can see exactly what we have over here. If I were to go into the insert lead angle, for example, we can see all the different ways that this tool is held, all the different holders for this type of tool. For example, I'll choose this one over here, and you can see exactly the way this tool is held. I can change all the parameters, the shank height, the length. If I were to open up the tool length, you can see all the different lengths that exist on this type of holder. The different type of shank widths I can use, for example, 20 millimeters as shown over here. All of this can be put in over here with ease. Just click and choose exactly what you need.